In section 6.5, we look at dividing polynomials. This is something that we did not do in chapter 5 because it's more relevant to rational functions. So let's go ahead and start with some simple examples here. If I want to divide a monomial like 15x cubed by a monomial like 5x, we essentially just divide the coefficients. And so in this case, 15 divided by 5 is 3. And then we divide the variables, and x to the third power divided by x to the first power is x to the second power. And so this is a relatively simple example. Dividing a monomial by a monomial simply involves dividing the coefficients, and then as long as the variables are the same, we can subtract the exponents. The second example is a little bit more complicated, but still relatively simple because we are still dividing by a monomial like 7x. But this time we have a trinomial in the numerator. And the way this works, according to common denominator, is we would just divide each one of the terms in the numerator by that denominator. And by doing this, you essentially create 3 problems similar to the one that we did over here. And so now if we simply divide, 28 divided by 7 is 4, x to the third divided by x to the 1 is x squared. 14 divided by 7 is 2, x squared divided by x is x. And 35 divided by 7 is 5, and the x's here cancel out. And so our final answer here is 4x squared minus 2x plus 5. Now in our next example, we're dividing a trinomial by a binomial. And this is drastically different. So I want to put in a box over here, don't do this. We do not want to take the same approach that we took for the last problem. Now, I'm not saying that this isn't true. This is true. This expression here is equal to the sum of these 3 expressions here. The problem is we can't do any simplifying here. We cannot cancel an x here, for example, because we have 2 terms. What do we do with the plus 6 if we cancel an x? That's not possible. So this does not lead to a meaningful outcome. So instead, what we need to do here is we need to use long division. And the way long division works, if you don't remember, is you take the numerator, which in this case is the trinomial, and you divide it by the denominator, which is the binomial. So this is the setup for doing the problem. Now from here you need to pay very close attention. When dividing using long division with polynomials, we only focus on the first term of the divisor and the first term of the dividend. So in other words, we only focus on x and x squared. And for this reason, both polynomials must be in descending order. And so what we're going to do is divide x squared by x. So let's think about what you get when you divide x squared by x. X squared divided by x is the same as x to the 2 divided by x to the 1. And if you subtract the powers there, you get x to the 1, which is simply x. So dividing x into x squared gives us x. Now what we do, just like you would have done with any long division problem with numbers, is you need to multiply x to the divisor. And when you multiply it, you have to multiply it by each one of these. And so x times x is x squared. And I'm going to write that down here. And x times 6 is 6x. Now, do you remember what to do next when you're doing long division of numbers? After you multiply? You subtract, right? So we need to subtract what we just got there, and you have to subtract both terms. Now, if we do that subtraction, notice that x squared minus x squared cancels. 10x minus 6x is 4x, and then the plus 24 we can bring down. After this, you repeat the process. So now we are dividing 4x by x. And again, you only focus on the first term. So if we take 4x and we divide it by x, this gives us 4. So x divides into 4x positive 4 times. And then we repeat the same process. So we take our dividend, the 4 here, and we're going to multiply that by x plus 6, just like we did before. So we have to multiply it by x, and we have to multiply it by 6. So when we do that, 4 times x is 4x, and 4 times 6 is 24. And it is a positive 24, but you'll notice that I don't write the plus sign. And that's because in long division, after you multiply here, you have to subtract the result. And when you subtract each term. And you'll notice that what we have left over here is 0. And this, of course, is what we call the remainder. And the remainder is not always 0. Please understand this. But our answer to this question now is what we have up here. That's the quotient. So when we divide x squared plus 10x plus 24 by x plus 6, the answer that we get here is x plus 4. Now, you might notice that this is not the only way to do this problem, and I want to talk about this really briefly. So to show you an alternative way to do this problem, let me write down the original problem again. We had x squared plus 10x plus 24 divided by x plus 6. Another approach that we could take to doing this problem is we could factor the numerator. We know that we can factor this trinomial by using our magic x. And when you do that factoring, you will get x plus 4 times x plus 6. And the denominator is also x plus 6. And you'll notice that if you use this method, you can identify that we have a common factor here, and we can cancel those out. And this gives us x plus 4. And I will agree with you that this is much easier. Isn't it? Isn't this method here much easier than doing long division? So if that's much easier, then why do we learn long division? Well, we learn long division because, unfortunately, this method here does not always work. Think about it. This method is only going to work when, number one, your polynomial in the numerator is factorable, and number two, there needs to be a common factor that you can actually cancel out. If these two factors are different, then we don't get a new answer. So unfortunately, this long division process is necessary. I don't want you to think that you will always be able to factor, because you won't. So let's try some other examples of long division. So in our next example here, we have x squared plus 10x plus 24 divided by x plus 5. And I just want to point out that if you use factoring to try to do this, the numerator does factor into x plus 4 times x plus 6, but the denominator is x plus 5. And you see the dilemma we have now? X plus 5 does not cancel with either of those factors. And so there's nothing we can do here. We didn't simplify, we just factored. We didn't actually divide anything. So unfortunately for this problem here, and this is what I was just mentioning on the previous slide, long division here is necessary. In fact, it's required. So let's go through the process. First, I'm going to draw a little long division symbol here. We put our numerator, x squared plus 10x plus 24, on the inside of the symbol, and we are dividing by x plus 5. And to do this, we just focus on the first terms. So we need to do x squared divided by x, which of course is just x. So when we divide x squared by x, we put the answer right above the x squared. So that's going to be x. Next, we multiply x times x and x times 5. And when we do that, x times x is x squared, and x times 5 is 5x. And then you have to subtract, or even better yet, think you have to change the signs here. And then doing the subtraction, the first term should always cancel out. If this doesn't happen, then something's wrong. And then next we have positive 10x and negative 5x, which is positive 5x. And then plus 24 we can bring down. And then we repeat the process. So now we're looking down here, 5x divided by x. So again, you only focus on the first terms. 5x divided by x is positive 5. So we put this up here, and then we multiply 5 times x and 5 times 5. 5 times x is 5x. 5 times 5 is 25. And then we need to subtract or change the signs. And this gives us 1 left over, right? Excuse me, negative 1. Negative 1, right? So now our remainder here is not 0. In fact, our remainder here is negative 1. And the fact that our remainder is not 0 is exactly why factoring up above did not work. The remainder has to be 0 for factoring to work. So what is our answer? Well, to understand how to write our answer, let me show you a real quick, simple problem. So a long time ago, you learned how to do basic long division. Suppose we wanted to do 16 divided by 5. If you did 16 divided by 5, you would say that 5 goes into 16 3 times. 3 times 5 is 15, and when you subtract, you get 1 left over. And again, that's your remainder. So when you first started doing problems like this, you would write your answer is 3 with a remainder of 1. Do you remember doing this? But then later on, you learn that you can write your answer a different way. You can write your answer starting with the 3, that's your quotient, and then you come down to remainder and you put that over your divisor, and you would write your answer as 3 1/5. So 16 divided by 5 is 3 1/5. Well, this is no different. So when we write our answer here, we're going to follow this same pattern, this circular pattern. So we start with x plus 5. This is the main part of our answer. And we're going to add the remainder over the divisor. And so it's that same pattern. This is your quotient. Then you're going to add your remainder, which in this case is -1, over your divisor, which is, coincidentally, your divisor is also x plus 5. So the answer here is x plus 5 plus -1 over x plus 5. And just a little side note here, you could also write this as x plus 5 minus 1 over x plus 5. It's the same thing, isn't it? So you have a couple of different ways to write your final result. So for our next problem, it's the same idea, but obviously we have a higher degree polynomial. But the same technique works. So we're going to start with long division. So we're going to take 2x minus 3 and divide that into 10x cubed minus x squared minus 3x minus 27. And again, it's the same process. So we focus on only the first term. And so we take 10x cubed and we divide that by 2x, and that gives us 5x squared. And then we multiply 5x squared by 2x minus 3. And 5x squared times 2x is 10x cubed. And 5x squared times -3 is -15x squared. And then you have to remember to subtract. And you got to subtract both terms. So we have to subtract this term, and when you subtract the negative here, it becomes a positive. That's very important. When you do the math here, you get 14x squared, minus 3x comes down, minus 27 comes down. And then you repeat the process. So we're going to divide 14x squared by 2x. And when you do that, you get 7x. And so next we have positive 7x. And then multiplying 7x times 2x is 14x squared. And 7x times -3 is -21x. And once again, you have to change the signs. Combine like terms, and then bring down what's left over there. And you keep going until you can't go anymore. So now what we have is we have 18x, right, the leading term here, divided by 2x, which is 9. So 2x goes into 18x, positive 9 times, and then 9 times 2x is 18x, And 9 times negative 3 is negative 27. And then you need to subtract or change the signs, and notice your remainder here is 0. And so our remainder is 0, which means our answer is just this, right? Because there is no remainder. And so the answer is 5x squared plus 7x plus 9. Now, I'd like to point something out here. We have not learned how to factor this polynomial in this class. You can't factor this polynomial by grouping. But our answer had a remainder which is 0, and I told you on the previous page that if the remainder is 0, it means you can do this by factoring. But if you don't know how to factor this, how are you going to use factoring? The point here isn't that we use factoring to do the division. The point is we can use the division to do the factoring. So think about that. Factoring and dividing are related to each other. Let's try another. And I'm going to speed up just a little bit because the process is the same. So in this problem, we are dividing x plus 1 into 5x cubed minus 4x squared plus 3x minus 6. We start by dividing the first term of the dividend, 5x cubed, by the first term of the divisor, x. So again, this term divided by this term. And this is 5x squared. We put that result up here, and then we multiply 5x squared times x, which is 5x cubed, and 5x squared times 1, which is 5x squared. Notice that when it's positive, I don't put a plus sign there. And again, that's because we're going to subtract. And when you subtract, these terms cancel. And here we get negative 9x squared. And then we can bring down the rest. And then we repeat. Now we're looking at negative 9x squared divided by positive x, which is negative 9x. Multiply negative 9x times x is negative 9x squared. Negative 9x times positive 1 is negative 9x. Subtract, which means change the signs, and we end up with 12x minus 6. Almost done. Repeat the process. 12x divided by x is positive 12. 12 times x is 12x. 12 times 1 is 12. Subtract or change the signs, and we end up with negative 18. So our answer is the quotient here plus the remainder here over the divisor here. Now, it's not good enough to just write your answer like this. You need to come back up here and say this is equal to 5x squared minus 9x plus 12 plus negative 18 over x plus 1. And as we said before, another way to write this answer, which is just a little bit cleaner, is instead of putting plus negative 18, you could just put minus and then 18 over x plus 1. So both of these are correct. In section 6.6, we look at a different method for division, and this is called synthetic division. And synthetic division is only used when dividing by a linear polynomial. That is a polynomial to the first degree. And also the coefficient of x needs to be 1. So it's useful if you're dividing by something like x plus 5, or if you're dividing by something like x minus 3. If we have some polynomial p of x divided by something like this, then we can use this method called synthetic division. The method is really simple to use once you know the basics for using this method. So what we do first of all is we write down all the coefficients of the dividend in order from highest power of x to the lowest power of x. So this is our dividend, 5x to the third power minus 4x squared plus 3x minus 6. And the coefficients in order would be 5, -4, 3, and -6. So I'm going to write those down, but only the coefficients. And this is our dividend. This is what we are dividing into. Now it turns out that when you're using synthetic division, the only number that you need to think about when you're dividing here is this number. And we're going to bring that number and we're going to put it into a box. And when we put it into the box, we're going to take the opposite of that number. So we see a positive 1 there. We are going to put a -1 in the box. Now the way this works is the leading coefficient of the polynomial, the 5 here, this is going to come down. It always does. And the process of synthetic division goes like so. You take the number in the box, which we'll call our divisor, and you multiply that to the number down below. So -1 multiplied by 5 is -5. And then these numbers here we are going to add together. So -4 plus -5 equals -9. And then you repeat the process. We take the divisor, the number in the box, and we multiply it to this number. So -1 multiplied by -9 is +9. And then we add these numbers together, which gives us +12. And then one more time, we multiply -1 times +12, which gives us -12. And we add these numbers together, and that gives us -18. And this number in the box that's left over here, this is your remainder. And these numbers represent the quotient. Specifically, these are the coefficients of the quotient. So what that means is that our final answer here is we take the number 5, that represents 5x squared, and then the number -9 represents -9x. 12 represents the constant term, which is +12. And the remainder is -18. So we're going to add the remainder over the original divisor. And the original divisor, of course, was here. It's x plus 1. We just bring that down here. And this is our answer. And once again, of course, you could change this plus a negative number into just a minus sign, like so. And if you look back on the previous page, you'll see this is the same problem, and we got the same answer using this synthetic division process. In fact, I'll take you there now. So here's the long division process. Notice the answer that we got here using long division. And here is the synthetic division process, which gives us the same answer. And once you get used to this method, this is a much easier method to use. Let's try another example. So here we have the polynomial 3x cubed minus 31x plus 15 divided by x minus 2. So again, the synthetic division process is that we need to write down the coefficients of the dividend in order. Now it's worth noting here that we do not have an x squared term. And that's important because you have to represent that with the coefficient of 0. So you need to think of this in this way. And so if we bring these coefficients down, we have 3, 0, negative 31, and 15. That's our dividend. Our divisor is x minus 2. So again, remember, we take this number and we're going to put it in this box here, but we have to take the opposite of that number when you put it in the box. Now, you don't have to write the plus sign. I'm just writing that to emphasize that we're taking the opposite of that number. And then the procedure goes that the leading coefficient comes down. And then we take the number in the box, multiply it. So 2 times 3 is 6. And then we add 0 plus 6 is 6. Repeat. 2 times 6 is 12. Negative 31 plus 12 is negative 19. 2 times negative 19 is negative 38. And 15 plus negative 38 is negative 23. And again, this number here is our remainder. And then the answer, the quotient, comes from these numbers. And so our leading coefficient of our answer here is 3. So one question is, well, how do you know what it is? 3 what? 3x to what power? Well, the simple idea is that when you take a third degree polynomial and you divide it by a first degree polynomial, your answer is always going to be a second degree polynomial. Every time you use synthetic division, the power of the original dividend is reduced by 1 in your answer. So this is once again going to be an x squared polynomial in our answer. So it is 3x squared positive 6x minus 19 and then minus 23 over the original divisor, which was x minus 2. So you need to know long division and synthetic division because once again, synthetic division only works when you're dividing by 1x plus or minus a number. But anytime you can use synthetic division, it's the better method. And so I'll just end this by saying synthetic division is awesome. Time to do some work.